Let's get started. 7 deadly deployment sins. Kind of a warning. This is more of a fun talk, but I guess since it was a long day, we will mostly make fun of stuff, and it's not as productive as other talks I do around those. So who was in my first talk today? Anybody? You? Okay. Yeah, I still work for Elastic, a company doing Elasticsearch, Logstash, Kibana, Beats. I work for our infrastructure team, so we do stuff like testing with Jenkins, doing containers, AWS, and some chef puppet automation. This is kind of the world where I mostly work more on the ops side of things. And yeah, this is still a Unix pipe. I kind of piped it out into developer advocacy just to talk about all the stuff that we do. So, are there any confessions? This will be heavily based on the movie Se7en. Like, I hope everybody knows that. And yeah, any confessions before we get started? No? Good. Which sin is that? Anybody knows the movie well?
It was Gluttony.
Yes, Gluttony. The overindulgence and overconsumption of stuff. Which is basically add all the things. So if you're a Java developer, it's often like not the thing that uses the least memory, and yeah. So if you add all the dependencies to a big Java project, it can use up a lot of memory, the permanent space, or now it's called meta space. Like all the dependencies you have in there need to be loaded up, and already that will take up some memory. And yeah, it then keeps on using more memory, and also the deployments will be big. So if you then get a jar or a WAR file, it will take up a lot of disk space. And some projects realized that it was kind of a problem. So like 1 or 2 years back, I used the AWS SDKs in Java, and they had a lot of services, but just one big dependency. So basically, as soon as you were using a single Amazon service, you had to add that dependency, and that was 13 megabytes. So every time you deployed or you started up something, you had these 13 megabytes, and you might just use one tiny chunk of that API. So if you're just using Amazon S3, their storage, you always need to have those 13 megabytes. And at some point, you realize for your dependencies, instead of just the 13 megabyte dependency. And then there is this famous quote that Bill Gates said to have done. The problem is having smaller dependencies can also be totally overdone. Is anybody doing JavaScript and Node and NPM? Anybody know? Yeah, so with NPM, I always have the feeling like they have the opposite problem. It's like tiny dependencies. And there I've seen people who say like the 640K challenge is basically to build a node project with having less than 640,000 dependencies in there. Which sounds totally ridiculous, but if you check out the NPM packages, you can see that it's not that far from the truth. So for example, somebody made packages for each and every emoji that is out there. Like one package per emoji. And you can imagine that you can add up a lot of packages if you start doing stuff like that. And it's amazing that if you look into those are even unit tested. They are basically packaging an emoji, the Unicode character, and they have unit tests with further dependencies in that. And the other thing you can do is combine all the projects, and again, you can totally overdo it to go into the other direction. Something that everybody needs to do now is called microservices, and lots of people kind of do it like that. Like the boss decided, like we're doing microservices now, and this is what we got. Like we have all these independent thingies, and they're pretty crappy on their own, but we have like small, tiny independent things now. Other people kind of have found a workaround for that. So if you just name them shortly enough, you still have microservices. Your services get short names, they're also very likely. But you don't really need to stop at that level. You can take it kind of further. So you can only start with microservices, and then you make nanoservices, Pico, Femto, Atto, and I think Yocto is the smallest thing I could find. So there's, I guess, just one line of code. But once you have reached that, you have the perfect Yocto service. It doesn't get any better than that anymore. Which might sound interesting, but reality is often not that nice. I've seen comparisons like that. Like, this is kind of the theory that looks kind of okay, but practice often isn't that perfect anymore. Like, it's just not that great. And that's probably the only good thing that Gartner ever made, their Gartner hype cycle. And you can see with every new technologies like microservices, like people start off with the technology, it's all great, and then they kind of fall down in this trial of disillusionment. And eventually, at some point, people might find this plateau of productivity, or they might just fall down further and abandon whatever they have done. So that's kind of the regular circle people are always doing. Like you had that with SOA was a thing a few years ago. Then everybody abandoned SOA. I still remember then there was NoSQL. Right now I think it's containers and microservices, but everything goes through these same cycles. And I'm not saying that microservices are bad. They can help, but only if you have specific pain points, because they're only taking away specific pain points. So if you have too many people in your project, or too many dependencies, or it's just not scalable, or you need to scale dependencies independently, or services, yes, that is going to help you, but it's not the silver bullet. It is not going to solve all your problems. So, yeah, it is not. Don't believe it, even if somebody tries to say it did. Common problems are, I guess everybody is familiar with those. Like if you have a distributed system, there are certain things that are hard in distributed systems, like latency and failures. Yeah, some microsystems, good old some microsystems now, wrote down in the beginning 7 fallacies, then an 8th one was added. The new version of that comes from Twitter. Who still remembers the Twitter fail whale? Anybody? Yeah, like, I haven't seen it in a long time, I must admit. But in the beginning of Twitter, like, you had the fail whale pretty much every week. And that was mainly due to growing pains. Like, they had a monolith, then it just toppled over. Then they started to split up, like, smaller services, or nowadays we would call them microservices. And it was a lot of growing pains. And one of the very interesting blog posts is from Jeff Hodges. He was at Twitter for a long time and worked there. Since then he has moved on. He has worked on Let's Encrypt and other very interesting projects. But he has basically written down the applied things they learned at Twitter and why they failed so many times. And their takeaway mostly was distributed systems are different because they fail often. So you have lots of components and they will fail independently, but your entire system should still work. Otherwise, if you fail, if just one little piece is failing, you will fail many, many times because like so many independent failures are possible. Then there are people who say like, oh, we've done SOA 10 years ago, we can just do the same thing, and now we're totally hip again and everybody loves what we're doing. I'm not so convinced. Like SOA has its own downfall, and you probably remember that one. It's called WS Death Star. Like, you know the WS standards in SOA, like you had one standard for everything, and nobody really understood them and implemented them correctly, and then everything crumbled again. Who uses Wireshark? Yeah, it's a great tool, right? As long as you have one big service. I used it quote already today. If you have like highly distributed system, like tools you have been using previously are not as effective anymore. So if you have the big monolith and you just need to monitor one server, Wireshark works very well. But if you have like 20 or 30 services and they're spread out, using Wireshark will become pretty painful for you. Another thing, Star Wars. Any guesses what that could be? Yeah, those are two microservices and their shared database. So if you do something like that, you don't get a distributed system and you don't get kind of the benefits of a distributed system if you still have something shared between them. So if you have this shared database and all your independent services use that shared database, if that database is going down, all your fancy little microservices will pretty much die with it. Pretty much like the fighter jets there. Some people are very cautious and like, yeah, you should not even consider building something complex as a microservice. Start off as a monolith. The majority of applications actually should be built like that, and that was said by Martin Fowler. He said, like, do pay attention to good modularity, like build it the right way, but probably don't by default start off as a microservice. But build something that you could afterwards probably split into different services. And he has in his blog post, so this is very nice comparison, new technology stack in 2005 and 2016, or it probably could be 17 as well. And you can see the things and moving parts you have here and the things you need to understand versus this one. Life is not getting that much easier. And to kind of be able to keep that beast under control, you will need a lot of knowledge and the right tooling, and you will need new things that you didn't need in the past. So always keep that in mind. Another view on that is has been done by Simon Brown, and he has like number of deployment units and modularity. So kind of the big ball of mud as a monolith, that is not good. But if you have the big ball of mud in a distributed fashion, it's probably even worse than the monolithic big ball of mud. What you really want to do is have the second axis of modularity. So if you have good modularity, then you have a modular monolith that can work well, or if you need to, you can also do a distributed microservice like with a proper modularity. But if you just like split up shit, it will still be shit. It doesn't fix that. And another thing is, it's kind of like an image problem. Like the monolith is just not cool anymore. So maybe you just need to rename it. So some suggestions I have seen is Mega Platform, Uber Container, or Stereolith. So if it was called something like that, maybe people would not do microservices anymore because you suddenly have a cool new name and everybody wants to do the hot new stuff. So next time you build a monolith, say you have a Stereolith, and it sounds way better. I actually would love to call it Serverfull. We will talk about serverless a bit later. So the thing is, microservices are great because you have all these little small, simpler things, but you basically push down the complexity to the integration layer. So the complexity doesn't vanish, you just hand it off. So if you're a developer and think, well, microservices are great, maybe the ops people will not be so happy with you after that, because basically you're throwing the complexity over the fence to them, and they need to take care of that. Yeah, and if you're a big team, yes, probably you're stepping on each other's toes, so you might want to do that. If you're a small team, yeah. Sam Newman is actually someone, he's kind of pioneering microservices, and he's both well-known and a big advocate for microservices, but still he is critical for small teams if it really makes sense. And yeah, everybody repeat after me, I'm not Facebook, Google, or Amazon. Like, just because they're using something doesn't mean you should, and it won't make you successful generally. Next up, greed. Yeah, it's written here, you know, that's pretty obvious. The excessive desire and pursuit of material possessions, and I have a single slide for that. Anybody has done that? I did, like many years ago. I can still remember, like it was the old days of JBoss, like it took 5 minutes to start up, and every redeploy took 90 seconds, and after 3 redeploys you had an out of memory, so you had to start up again. I have heard stuff got better, and now I know it's Wildfly, and everything is much cooler. But yeah, I still have kind of bad memories to that, but I think even in the Java ecosystem we mostly got rid of that something is extremely heavy. The Java ecosystem saw at some point that it's going to help anybody. Anybody knows what sin that was?
Sloth.
Yes, that is sloth. The laziness. Don't be lazy. I'm emphasizing the spiritual laziness here. And for me, that is kind of in the continuous integration development deployment area. So continuous integration is every time you push code or you commit it in Subversion, it should be tested. Who's doing that? That is not that many. Okay. The general idea is every time somebody publishes some code, it gets tested. So you see very early on that something breaks. Maybe you even have something like pull requests. So before you merge it into master or the main line of development, it gets tested and you see A compiles and B tests pass. I think that is kind of a good idea. The next step is, can you do continuous delivery? you have your artifacts built automatically and pushed out to development automatically. So development will always get the current master branch, but not production. Production is done manually. And the final step in that development is basically you do continuous deployment. So even to production, all the changes are rolled out automatically. Is anybody doing that? Okay, a few. Very nice. Is it working well? Yes? Okay. I assume you have some kind of good test suite and you do code reviews and yeah, you have kind of the proper setup, then this can work well. If you don't have that, yes, it can also go very wrong. And to put all the buzzwords into one slide, yes, first you do agile, then we do the various stages of continuous something, and at the very end you have DevOps. Whatever DevOps is, but here you have all the buzzwords, and yeah, if you do that, you must be doing everything right. Then there's the common question like, continuous deployment, is that really a requirement? I'm myself not really convinced. It can be for some people if like moving fast is your main objective. For others it might not be that important. But I think you should have kind of some automated way to roll out your code and it should be very quick. Like if you cannot deploy what is in your main line today, I assume you're in trouble in general. But don't just trade speed for correctness, because you don't really want to have that one. So 60% of the time the deployments work every time. That is not really. So just trading speed for that is probably not a good idea. I'm using Jenkins. Can now say various things about Jenkins, and depending on the day, we see that differently. So sometimes it's the Jerkins that is failing on purpose. Sometimes it's just junk because we're incompetent, and sometimes it's junk because for no real reason. Who's using Jenkins? Okay, a few, yeah. Do you like Jenkins? Yeah, okay. So, yeah. We have internally at Elastic, we have lots and lots of Jenkins servers, I think 40 or so, and we have one person who's doing Jenkins basically full time, and two who are helping out, and they really hate Jenkins by now. They are even thinking about writing their own tool now, so which is normally a sign of pretty big desperation. Yeah, what I still think what you should do is separate code and configuration. So what I've seen fail badly if you have your configuration and credentials and stuff like that baked into your artifacts, because you don't really want to rebuild your artifacts if you just change some credentials. Like if you change your passwords for your database or whatever, you don't want to rebuild your artifacts that you deploy. Keep those separate. And the other thing is, never commit your credentials. That is normally the best way if you have some AWS credentials, for example, to get them stolen. And then your instances start mining bitcoins, and it can get very, very expensive. Like I've seen lots of people who have AWS bills between 10 and 50K because they had some internal project, they committed their credentials. At some later point, somebody who didn't know about those credentials thought it was a good idea to open source the project. And nobody really knew the credentials were there, but the bad guys are just continuously scanning GitHub and trying to find those credentials. And AWS is doing the same now, and blocking any credentials, it's fine, it's in the open. But this is pretty much a race, like who is quicker to find your credentials, like the bad guys to exploit them, or the good guys to block them. Don't rely on AWS to be quicker than the bad ones. Which thing is that? It's probably hard to see. Plus an intense and uncontrolled desire. And I always say like, this is always use the hottest shit. It's kind of, I guess most of you know that like you want to use the technology and you're just looking for the right project to do that, or where you can sneak in the technology. It doesn't really make much sense, but I really want to work with containers maybe. So containers are great if you have the problem of, but it works on my machine. So I guess everybody had that colleague, I had it. His code would always work on his machine, but nowhere else. And our solution was then to tell him at some point, like, okay, back up your email, because your laptop is going to production now, since this is the only system where this is working. So yes, Docker is helping you with that. The problem is, Docker is not solving all your problems. So if you containerize everything, you could end up with something like this. Yes, everything is nicely containerized, but you didn't really reach your end goal of having a stable application. Or another view on that is everything is like tires, and it's looking something like that. It's very easy to understand because your whole system is tires. It's big tire fire, but it's all tires, so yeah. And unfortunately, containers will also not fix your broken architecture. Yeah, that's not working out. Why? Let's take that picture. So we have these containers, and each container is doing pretty well on its own, I would say. Like, they're doing fine, but your project in general is probably not that well off right now. Even though you're using containers and it's great, like containers all the way. Or yeah, you're still using glibc, so you're not on Alpan or something like that. There's a security vulnerability in glibc, and suddenly you need to re-roll all the images to fix that, to get a new base image. Yeah, so also security is kind of something that gets not that much easier. And then there is this meme from the movie Downfall, where it is highly amusing. It's just like 4 minutes or something like that. I can highly recommend you to watch that. Two things that are very common. When Hitler throws out his generals, he's asking like, who is using Docker in production? And just to get an idea, who is using Docker in general? Here? Who is using Docker in production? Yeah, okay, it was not a tenth, but like a fewer hands. So that is one of the common things. And then you have this thing like, yeah, you run Docker on Google Compute Engine in instances on board, so it's kind of lots and lots of layers. And all of the layers are fine, but they will introduce some complexity and something that could break, so it's not getting all of that easier. That's a containerized legacy application. So yes, you could put your COBOL code or something like that in a container, but this is not fixing your COBOL problem. It's just like putting it somewhere else. And some people always like this cult thing, like, oh, the big successful companies are doing containers and microservices, so if we're doing the same, we will be successful as well. Dilbert shows it very nicely when they find out that the big successful companies do golf tournaments. So they will do golf tournaments now and then be very successful immediately afterwards. That is what a lot of people, I think, do with containers and microservices. That, yeah, somebody is successful with that. So if we do that, that is kind of immediate reaction will be successful. And a lot of people don't really care about the problem anymore. They have a solution, and it is, I don't know, whatever currently they want to do, and for some it's containers. Yeah, and Kelsey Hightower, he's the Kubernetes developer advocate from Google, so he knows what he's talking about, and he loves containers. But even he says, like, don't use containers just because Google does, because Google also writes their own file system, and probably you don't want to write your own file system, or it's... Has anybody tried to write their own file system? No? Good. Yeah, and some people are just saying like, yeah, everything needs to be so fast, but we're kind of trading the correctness. That might not be worth it. Like, just being fast and wrong is, yeah, yes, you're fast, but you're still wrong. And then there's this assumption, I hope there are not too many JE people here, but I always say, like, make jar, not war. So you build one big jar file and you don't need an application server anymore. And then if you have an AWS image with the JDK, that's pretty much like a container anymore because you have all your dependencies in your jar file, they don't change anymore. You don't have any big external dependencies, so maybe you don't even need containers for that. And yeah, serverless, everybody needs to do serverless, right? It's the new hot thing. And yeah, it's eating up microservices now, I guess. Since basically it's function as a service, so all your little microservices are inferior to be eaten up by something even smaller. Yeah, and today we're doing serverless, tomorrow we're doing protest, and then it's basically architecture. So yeah, that's kind of just, it's around the corner. Some people say it's pretty much platform as a service reborn. I can still remember a few years back at university, everybody told me like infrastructure as a service, nobody wants to use that in the future anymore, do platform as a service. Like you have this environment where you just put in your jar file or whatever artifact you have, and it's just being run for you. It didn't really work out. And some people are like, oh yeah, maybe this is the thing. And yes, it is platform as a service. If you're good on platform as a service, you could start up in 20 milliseconds and you can bill it by the hour. That is kind of two of the very nice features, that you just run these one-off jobs, like a little cron job. Instead of having a server sit there the entire week to run a cron job once a week, you just pay for serverless function, and that costs you maybe a cent a month then, instead of like $10 or whatever. Pride. Yeah, thinking that one is essentially better than others. Who is a developer? Who is ops? Yeah, okay, very few. So that is kind of something like, yeah, for developers, working for me now it's an ops problem. Like I do all the fancy microservices, or I will just do this new NoSQL data store or whatever. Like I will work on it for 2 weeks, and ops then need to support it for the next 5. So kind of don't be too proud of what you do and just look for yourself. That DevOps thing is not mainly about technology, in my opinion. It's more about like combining and also seeing like what is going on the other side and how you can make the end result better. And also don't do it like that. Yeah, we do DevOps without all the content basically. So yeah, you can, if you're some big company that, I don't know, might be sponsoring the conference here, I don't know. I don't know what they're doing, but you can still write DevOps kind of somewhere on the top, and then you just do DevOps with all the actual things in the background. What is that? Kevin Spacey is not the answer. That was envy. And I guess everybody knows that, like, or you know some colleagues who have that, the not invented here syndrome, like you want to build everything yourself. Because, I don't know, either you're too lazy to read documentation, or you just want to have job security because nobody else can maintain it afterwards. But yeah, some people have that. If you're a dev, like Java ecosystem was kind of prone to having that you had to handcraft your starting point for Java application. Spring Boot kind of countered that. You just have kind of the same base, and you just start off with that, and you're having the same base as everybody else, and it's very easy to transfer knowledge and build that. So that is very convenient to just say, I want to have this artifact, and I need, I don't know, we need web security, JPA, and I don't know, a few other things, and we kind of put together the right artifacts, and it will know what works together and have same defaults for you, and you can just start writing your projects. The other thing is around infrastructure. Who knows PEPs versus Kettle? Okay, that is just a few. So PEPs is what you did previously. Like you got, I still can remember when I got my first virtual server, it was like a pet. It got a name, I raised it by hand by installing every package, I configured it, and if my pet or server was sick, I cared for the server and tried to fix everything. It was a loving but very slow process. Whereas Kettle is kind of the new thing. Like Kettle, they don't have names. They are not raised by hand, they're kind of raised automatically. And if they're sick, they're shot, or at least removed from the herd. Because otherwise they just infect the rest of the stock. So you get rid of them. And that is pretty much the infrastructure side, that you don't keep your configuration files somewhere and then you try to fix stuff and recreate what you had there, and you're always afraid that some server you haven't really backed up will crash and you are never able to really recreate that one. No, it should be kind of automated. Yeah, just some instances might be special. So the Redis instances, they might be special. They even get deals. So I'm a big fan of Ansible, but Chef, Puppet, SaltStack, whatever works well. It just at least 80% I would say of your infrastructure should be automated, so it should be easy to regenerate whatever you have been doing. And I also really like Terraform to create your resources in the cloud. So it does all the cloud providers basically. You can even manage your GitHub users now, your domains, pretty much everything. So that is very nice to automate that, and you don't really rely on you remembering next year what you have done today. because that will probably fail. So yeah, I'm all for automate all things. And the main goal is to avoid drift. So stuff changes over time and you kind of lose that drift, and then when you kind of try to regenerate from the beginning, you don't really have the right settings. Or you could have the drift that your development and production environment kind of drift apart, and then it doesn't make that much sense to test anymore. Unless, if you develop in production, you don't have that problem. Like, that might be a good argument for that. Like, you don't have drift anymore. But this, which thing is that? Red, yeah. So, stuff can go wrong. You should have some logging and monitoring. So, if that is your approach, that might kind of work. Like, I used to have Dropbox on my computer, and for me that was designed because Dropbox has kind of the icon changes when it can reach the network connection, and then it was normally super quick to detect if the network was up or not. But that might work for my laptop, but it's probably not really what you want to do for your production. So I talked about that before. Like we have some stuff around that. We have our open source products which you can use. We have our cloud offering. We have some commercial extensions for that as well. But they're helping you to collect your logs and monitor stuff. And then you don't rely on YouTube anymore. Then you get something like that where you can see, okay, where are my visitors coming from? How many visitors do I have? How much traffic do I have? Do I have anything out of the ordinary? It's kind of just to keep the overview. To conclude, we have seen a lot of things. I guess everybody can kind of think for themselves, like, of which you're guilty or not. Like maybe some are more the lazy feature or the lazy side where you don't do any automated tests. The others might be more of that, I always want to use the hottest shit. Like it's always kind of thing to find the right balance. If you have forgotten everything about the movie Se7en, there is I think it's 2 minutes or 3. An 8-bit version which basically looks like that and has the authentic 8-bit music in the background to walk you through the movie in 4 minutes or something like that. Any questions or confessions? Yes.
So what would be a good line of reasoning for justified use of Kubernetes? When if you say, well, that person says, don't just use Kubernetes because Google is.
Yes. I mean, Kubernetes is getting very popular, but what is your main motivation? Like, if you need to spin up stuff very quickly and it's changing very often, I'm pretty much good for that. I'm generally like for for stateless stuff, I'm pretty open to containers because there it makes sense. You just bundle them together, you roll them out, you replace them. That is very easy. Where I'm more critical is for stateful stuff, because it's not just as easy as like having a load balancer and replacing a few containers behind it and then just pointing to the new pods. With stateful stuff, it's normally more complicated. But in general, I'm not saying that Kubernetes is a bad technology. I would just say like it will depend on what you need to do, and you need to look into that. Don't use Kubernetes just because Google is doing that. I don't think there is a global answer like use Kubernetes if you do X. It will really depend on your requirements and your environment. It can work well. I know a lot of people who are successful with it, but I would not just do it because it's fancy. Right? Be honest to yourself and find a reason, and don't just use it because it's hot. Other than that, it really depends. We can do Kubernetes monitoring in the next major version as well. Like we get the metadata out of Kubernetes, and you can still put it in our stack. So we don't have anything against Kubernetes. We just don't support it as for orchestration ourselves yet. Again, because stateful stuff is kind of harder than stateless stuff. And I think also Kelsey Hightower from Kubernetes, I think he also had some quotes about like he's all for it for stateless stuff, but for stateful, even he like is careful and says like you need to have a lot of operational experience to actually do that correctly. Any other questions? No? Then thank you.